Next is interconversion of energy. Interconversion as the name suggests, it is the conversion of one form of energy to the other form of energy. Let's see the definition. Energy conversion, also termed as the energy transformation, is the process of changing one form of energy into the another. One form of energy changes to the other form of energy. Energy conversion occurs everywhere and every minute of the day. Yes, in our day-to-day life, everywhere one form of energy is converted to the other form of energy. In your houses also, when you switch on the fan, what happens? Electrical energy is converted into the mechanical energy of the fan with which it is running. Then the same way, when you switch on the bulb, electrical energy is converted here in the form of light energy. When you cook food, electrical energy is the heat energy is converted into the chemical energy of the food. The same way, different types of energies are converted into other forms of energy in our day-to-day life. Let's see an activity. You can see here a pendulum. In this pendulum, when the pendulum goes to the extreme positions, you can see U is increasing. What is this U? U is the potential energy and K is the kinetic energy. As the pendulum is going to the extreme positions, the U increases, means the potential energy increases, and as the pendulum is coming down, the kinetic energy is increasing, and when it reaches to the mean position, its kinetic energy is 0 as well as the potential energy is 0. Once again, when it goes to the extreme position, potential energy increases and kinetic energy becomes 0. When it is released from the extreme position, again the kinetic energy increases, potential becomes 0. So this is how the energy is always converting. One form is converted into the other form. Same way, here you can see the bow and the arrow. To have more potential energy, we have to stretch the bow back. You can see here the girl is stretching the bow back, so that, see, as much as you take it back, as much you displace the bow from its mean position, it will acquire the same amount of potential energy, because we are doing work in taking the bow from the mean position to the extreme position. So whatever extreme position you are taking, whatever work you are doing in taking it from its mean position to the extreme position, it is stored as the potential energy. And when you release the arrow and the bow from there, that potential energy is converted into the kinetic energy of the arrow, with which it is going away from the girl. Right? This is how the energy is changing from one form to the other form. It is called energy transformation. You can see there's an activity given on the book also, where different types of energies are given, how they are changing, and their examples are given. Beta, just go through this table given on the book and learn it carefully. You might be asked questions out of this table also, how the energy is changing, or give example of the change of the energy from one form to the other form. Just go through this and do learn this table. Next is law of conservation of energy. Law of conservation of energy states that energy can neither be created nor destroyed. It can only change its form. We have learned already that it is changing from one form to the other form. It means that energy is not being created or not being destroyed. It is always changing its form. It is changing from one form to the another form. In other words, total energy is conserved during transformation of energy. So we can say the total energy is always conserved. Now you can see this again. The pendulum, always energy is changing from potential energy to kinetic energy, right? We are saying that the energy is neither created nor destroyed. It is always changing from one form to the other. But then there's a question. This we have already know that potential energy changes into the kinetic energy here. So, but there's a question that why does it stop swinging after some time? If it is always changing, the potential energy changes to kinetic energy, it means that the pendulum must always be in motion. Why does it stop after some time? Well, it stops because the air friction and the friction of the hanging point, because now the friction and air friction has to play their role. Because of them, some part of the energy is lost. Same way, electrical energy is converted into the light energy and some part of the energy is converted into heat energy. When we switch on a bulb, yes, electrical energy is converted into the light energy, that we all know. But the same amount of electrical energy is not converted into the same amount of light energy. Some part of that energy is used in heat energy. When you touch the bulb, after blowing it for some time, you will feel that it is very hot. You will not be able to touch that also. Why? Because some part of the electrical energy is also changed into the heat energy. So, the total energy, that is heat energy, amount of the heat energy plus the light energy is equals to the electrical energy. So that is why it is said that the total energy is always conserved. It is neither destroyed, neither created, but the total amount of energy is always conserved. However, some part is useful and some part is not useful for us. So we can say some part of energy is not changed to useful energy. It is spent in transformation to meet ground friction, air friction, resistance, opposition or heat and so on. So, in heat energy or resistance or air friction or opposition, it is used in this type of oppositions, so that the total energy is always met. Thus, law of conservation of energy is stated as energy is conserved during transformation of energy in the absence of losses of energy due to friction and other reasons. So, we can say the transformation or the energy is conserved only if there is no friction or there is no other reason for the unuseful energy, right? So, in that case, we can say that total energy is always conserved. Otherwise, it is used in different, it is used in meeting the other frictions or oppositions or resistances. So, if there is no resistance and no friction, it will always be conserved. Next, roller coaster example is given on the book to make you understand about interconversion of energy and the conservation of law of energy. So, in the roller coaster, this is how the energy changes. You can see when it is on the height, the potential energy is increasing, and when it is coming down, kinetic energy is increasing. Again, when it is going up, it is potential energy is increasing, and when coming down, kinetic energy is increasing. So, when it is at a height, it has potential energy. When it is released from that height, it gains the kinetic energy, right? This is how it happens. When it is at the height, potential energy. When it is coming down, there is kinetic energy. So, as a coaster car loses height, it gains speed. Potential energy is transformed into kinetic energy. As a coaster car gains height, it loses speed. Kinetic energy is transformed into potential energy. So, the sum of kinetic energy and potential energy is here constant. It means that total energy is conserved here. Next is hydropower plant. Again, an example of law of conservation of energy. Here also you can see that the reservoir has the potential energy. Here the water is having the potential energy, and when from the reservoir the water is released, it gains kinetic energy, and that kinetic energy is used to run the turbines. From here the water goes and the turbines are running. From here, from the turbines, the generators produced electricity. So this is how the energy changes. The reservoir has the potential energy. From there, the water has kinetic energy. Through the pipes, it goes to the turbines. Turbine also has the kinetic energy. That kinetic energy is used to run the generator, and that generator produces the electrical energy. So this is how the energy changes in case of a hydropower plant. Same type of flow chart is given for a roller coaster also in the book. Just go through that also, beta. Next is your homework. So that is it for the chapter. Just read the chapter carefully